Hello everyone, welcome back to my channel. So today we are going to discuss another problem. But before going forward, if you have not liked the video, please like it, subscribe to my channel so that you get notified whenever I post a new video. Without any further ado, let's get started. So the problem is maximize distance to closest person. A very interesting problem. You are given an array representing a row of seats where seats I is equal to 1, representing a person sitting in the ith seat. Means if the value is 1, means there is a person sitting on that particular seat, ith seat. And if the value is 0, means that seat is empty. So there is at least one empty seat and at least one person sitting. So there will be an empty seat and there will be a person sitting in that row. And Alex wants to sit in the seat such that the distance between him and the closest person to him is maximized. Right? Means the distance between Alex and the person which is next to Alex, that distance should be maximum. Means Alex wants to sit as far as possible. Right? So we need to return the maximum distance to the closest person. So if we see this test case, this is the test case given. Means over here 1 means that here a person is sitting. Here a person is sitting, and 1 means like wherever 1 is, that means a person is sitting, right? And wherever 0 is there, it means that seat is empty. This seat is empty, this seat is empty. So we have to sit, Alex has to sit at a seat such that distance between Alex and the person should be maximum. So see, if Alex sits here, then the distance between Alex and this person is like one only, like they are at the same, they are sitting together. So this is not the maximum distance. If suppose Alex is sitting here, then also the distance between Alex and the person is 1, right? If Alex sits here, then also the distance between person and the Alex is 1. But see, if Alex is sitting here, if Alex sits here, this is also an empty seat, then the distance between the closest persons, this is one closest person, this is one closest person. So distance between Alex and the closest person will be 2, So in both sides, from both sides. So the distance, maximum distance will be 2. Alex can sit here because this seat will, if Alex sits here, then the distance between Alex and the closest person will be maximum. If sits here, let's say we take Alex is sitting here, then you will say that okay, this distance is 1, but this distance from Alex to this person, this is 3. Then obviously, so we will not consider like this, because see, we have to find the closest distance between the person with the person and the Alex. So over here it's 1, even though this is 3, but since this is less, this is minimum, this is less distance na, 1. So we have to like consider both the sides, from left also and from right also, and then from that we have to take the minimum because these are more closer. So this seat does not give us the maximum distance, right? So if you understood the problem, you this might come into your mind that okay, so we have to consider distances from both left and right, left and right. So this is one observation which we can make from this test case. So I hope you understood the problem. So the output for this will be 2. Why 2? Because we need to return the maximum distance. We have to return the maximum distance now. And maximum distance will be when Alex will sit here. Alex will sit here. If Alex sits at this position, at this seat, then in both the directions, the closest person to Alex will have distance 2. Right, 1, 2. So I hope you understood what the problem is. Let's see how we can approach it. So see, just pause the video and think that if you have to find out, like for each, over here, for each position, we have to find that what could be the minimum distance from both left and right, from both left and right. Like for example, if Alex is sitting here, what will be the distance of Alex from this left person, and what will be the distance of Alex from this right person? If we have both these values, then we can obviously simply find out what is the like minimum, what is the closest distance, right? So just pause the video and try to think how you can do it. So I hope you have got some approach, and if not, don't worry, let's see. So see, what we will first discuss brute force approach, and then we'll go to the optimized approach. So we have 1 and 0. This is the test case. See, what we incurred from the approach, like what we incurred from the discussion, that we have to find out, like suppose 1 is here, 1 is here, means at this seat a person is sitting, at this seat a person is sitting, these are the empty seats in between, right? So for each of this empty seat, we need to know, if Alex sits here, then what will be the distance of Alex from this person, and what will be the distance of Alex from this person. Let's say this is 1 and this distance is 4. So the distance between Alex and the closest person will be 1. Why 1? Because we will take minimum of this left distance and right distance. Why we are taking minimum? Because see, even though this person is far away from Alex, but this person is closest to Alex, so we have to take the closest one, because we have to, in the answer we need to return the maximum distance from the closest person. This could not be an answer. 4 will not be, because if Alex will sit here, then this is also a person sitting next to Alex now, so that will also consider. So minimum of left distance and minimum of right distance we have to take, right? So here it will be 1. Minimum will come out to be 1. So Alex will not sit here. Let's say Alex sits here. Then the left distance will be 2 and the right distance will be 3. Then your minimum will be 2. And if Alex sits here, let's say Alex sits here, then again distance will be 3 here and it will be 2. So maximum distance between Alex and the person could be 2. Right? So now let's see how we will do this. So we need to find out left distance and right distance every time now. So what we will do is, we will have two arrays, left distance array and right distance array. So see, for each of this empty seat, like for this empty seat, we need to find out what is this distance between this empty seat and the closest person, and what is the distance between this empty seat and the person which is here, like the person which is closest. So what we will do is, we will make an array. We will have an array of same size. So let's have an array. It will be same size of this array, 4, 5 and 6, right? And this will be right array, 0, 1, 2, 3, 4, 5 and 6, right? So initially let's give a maximum value, 7, 7, 7. Size, this is n is equal to 7. There are 7 elements. So just give any maximum value. Let's say we are giving 7 initially, right? Now see, we have to find for this position, like when we are here, we need to find out what is the distance between this seat and the closest one to the left, closest one. So over here we already have 1, so the distance will be 0 only. Between this seat and the 1 is 0, right? So means if over here ARR of I is already 1, ARR of I is already 1, so over here the left distance array will have value 0. Then over here, at this position, this is 0. So we need to find out what is the distance between this seat and the closest one. So it will be the previous distance of this seat plus 1. That is, if it's not there, if it is 1 over here, here 1 will come. Else what we need to do is the distance will be left distance I minus 1 plus 1. Why plus 1? Because we are this is one distance na? We are taking the previous value and we are adding 1 in it. So what is the distance till the previous value? Plus 1. So here it's 0. So here it will come 1. So see, distance between this 0 and the closest one is 1. Then similarly for this 0, we will take the previous value and we will add 1. So this will become 2. For this 0, it will become 3. Then again 1 we got. So distance between this seat and the closest one is 0. When 1 will come, we'll write 0. For this 0, it will be 1. And for this 1 again, we'll have 0. For this 1, why 1? Because 0 plus 1. So this is the left distances for each of these seats. Right? Like for example, for this 0, the closest one to the left is at distance 3. Right. Similarly, what we will do is we will find for the right. So for the right, we will start reversing from the end of the array because we need to find the right distance. So for this same logic, right? Here it is 1. So the distance will be 0. Distance between this seat and the closest one. So here 1 is only there, so it will be 0 only. Then for this 0, it will be right distance of I is equal to right distance of I plus 1. Here plus 1 will be there, plus 1. So index will be I plus 1 because this index will take right. So this will become 1. So you see distance between this and this is 1. Then 1 is again there, so we will write 0. Then 0 is there, so that will become 0. Distance between this 0 and the closest one to the right. So this is 1. So 0 plus 1, 1. Then for this 0, it will be 2, 1 plus 1. Then for this 0, it will be 2 plus 1, 3. And for this 1, it will be 0. See, so we have found out for each of these seats. So for example, if you see this seat, for this seat, the distance of the closest one to the right is 1, and the distance between this seat and the closest one to the left is 3. Right? So I hope you understood what we have done. Now simply we need to consider which is the maximum. We have to find the maximum closest distance. So maximum closest distance, maximum distance to the closest person we need to return, which will be minimum of left distance comma right distance. So there might be a confusion that why we are taking minimum. See, minimum why we are taking is we need to consider all the cases. See, when we are over here 3, when we are at this seat, although the distance between this is here it's 1 and here it's 3, we will not be taking maximum of left distance and right. Why we are not taking maximum? Because then the answer will become 3. But 3 is not an ideal answer because although the distance between these two are 3, but distance between this and this is 1. So closest is this distance. We have to give the maximum. So maximum will be minimum. Will be taking minimum. So if you see all these, so the minimum will come out to be 2. Like 0, minimum of 1 comma 3 is 1. And then we have to basically take maximum of all the minimums. So we over here 2, we will take 2. So 2 will be our output. So minimum of left comma distance and right distance. So this 2, if the Alex will sit here, then the maximum distance will be 2 in both sides. So this was one approach. If you are not able to get it, don't worry. This is not an optimal approach. It was a brute force approach. Generally, when we see this problem, this approach comes into our mind. So time complexity for this is O of n, and space is also O of n because we are taking arrays. Now let's see one more approach, which is the optimal approach. And if you are having trouble understanding the previous approach, don't worry. This approach you will completely understand. So let's take this test case again. 1 0 0 0, and then we have 1 0 1. See, over here we need to find out the, like, where should Alex sit so as to get the maximum distance from the persons, right? If Alex will sit here, then Alex will get maximum distance from this one also and maximum distance from this one also. If Alex sits here, then Alex will not get maximum distance from this one. This one will be closer to Alex. So this is not correct seat for Alex, right? So see, when you are checking this out, when you are checking this, what you see, you will see that we are checking for the consecutive zeros. Consecutive zeros. If there are, like, see, if there are is one is here and there are many zeros in between, these are many zeros in between, and then one is here, then what you will see is, if Alex will sit in the middle of these all zeros, in the middle of all these zeros, then obviously the maximum distance will be there, no, between Alex and the ones, right? So just pause the video and think how you can use this point to think of the approach. So see, what we are doing is we are checking the consecutive zeros between ones. Between these two ones, if we know the consecutive zeros, how many are there? 1, 2, 3, 4, 5, 6, 7 and 8. If we know that there are 8 zeros between two consecutive ones, then we can divide this 8 by 2, 4. So we will know that, okay, there will be maximum distance of 4 between Alex and the ones in both sides, 4. So this is one approach you can use. Similarly, in this case also, in this test case which we were seeing, over here if we see the consecutive zeros, how many maximum consecutive zeros are there? Zeros. So over here there are 3 consecutive zeros. So 3 divided by 2, 1.5, just take the seal value, so this will be 2. So there will be maximum distance of 2 of Alex and between the ones, right? So this is one way of approaching this problem. Very easy, right? We just need to check out the maximum consecutive zeros and we'll divide them by 2. So maximum consecutive zeros divide by 2. There is one problem in this approach, right? One problem. See, if we take this test case, 0 0 0 0 and 1, take this test case. So in this test case, what will happen is, over here if you see, you will find the consecutive zeros, those will come out to be 4, and you will divide it by 2. So the maximum distance will be 2. So, but this is not a correct answer. Why not correct answer? Because Alex will sit here, because there is only one one, na? So Alex will obviously sit as far away possible from that one, because we have to find the maximum distance, na? So in that case, 1 2 3 and 4, so answer should come out to be 4, but we are giving answer as 2 according to our this algorithm, according to our this approach, which we were thinking when there were zeros between two ones. So this is an exception. So in order to avoid this could be in this case also, like if 1 is on this side, if this is the case, then Alex will obviously sit here, na, as far away possible from this person. But according to our approach, the answer will come out to 5 divided by 2. It will be 5 are the consecutive ones. So it will be 2.5 and it will be 3. So according to our assumption, Alex should sit 1, 2, 3. Alex should sit here. But Alex is sitting here. Right? So I hope you're getting what we are missing over here. So in order to avoid this, there is one way we can avoid this. See, let's take this test case. We have 0, 0, 0, 0 over here. And then we have 1. And then we have 0, 0, 0. Take 1 here, and this is the test case which is given. So just do one thing, pause the video and think that how we can avoid the earlier problem we were getting. So earlier problem was that sometimes there were prefix zeros. These are prefix zeros, like before this one, Sometimes there were suffix zeros, that is after this one suffix, and sometimes there were middle zeros which were between two ones. So how you can avoid these? So just pause the video and think. See, over here if you see, these are the prefix zeros, these are the middle zeros, and these are the suffix zeros, right? So let's take one more zero here. Now if you see how we can get to the answer. So answer for this will be here. Obviously Alex will sit here because if this is the maximum distance between from the closest person, right? So what we will do is we will have three variables. Prefix, which will give us the prefix zeros. Over here prefix zeros are 1, 2, 3, 4, 5. Then we will have a variable which will give us the middle zeros. Let's say it is a max zeros which is in between. So it is 1, 2, 3, 4. And one variable we will have which will give us the suffix zeros. Suffix zeros, which is 3. And then after that what we will do in order to find out the maximum distance? 5 will be as it is. We'll take 5 as it is. 4 will take as it is. Do you think 4 we have to take as it is? No, we will not take 4 as it is, because these we saw earlier na, that when we have middle zeros in the between, we divide the consecutive zero count by 2, because that will be the distance between Alex and the zeros. So for this we will divide max zeros by 2. That will be our distance, max zeros by 2, and suffix we will take as it is because Alex can sit here. So this is the distance between them. So what we have to take at last is we have to take maximum of whatever the prefix zeros we have, whatever the max zeros divide by 2 we have, and whatever the suffix zeros we have. So this will give us our answer. This will give us our answer. So here maximum of 5, 4 divided by 2 will be 2, and 3. So the maximum distance will come out to be 5. So Alex will sit here 1, 2, 3, 4 and 5. So this is the max distance between Alex and the closest person. So I hope you understood this approach. This approach is very simple. Just we need to take care of the prefix zeros and the suffix zeros. So let's quickly dry run. Let's quickly dry run on this test case which was given in the question. 1 0 0 1 0 1. So 1 0 0 1 0 0. Here it was 1. Right. Let me do the indexing. So 0 1 2 3 4 5 6. Okay. So now see what we'll do. We'll have three variables. Prefix zeros. Initially take it 1 minus 1. Suffix zeros. Take it minus 1, and max zeros, which will be the middle zeros, minus 1, and one zeros variable which will tell us the current count of zeros. Initialize it with 0. So see, we will start the traversal. 1 come. So here see, if you see, before what were prefix zeros? Prefix zeros were the zeros which were before the first one. This was the first one, and before this one all the zeros were the prefix zeros. But over here this is the first one, but there was nothing after before this, na? So there will be no prefix zeros. So what could be one case? That if we get 1, so see, this is the pseudocode which I am writing. If we will get array is 1, either we will get 1 or we will get 0, else we get 0, right? When we get 0, we will do one thing. We will just increment zeros variable, zeros plus plus. But when we get 1, means we need to check that if the prefix zeros variable is equal to minus 1. Means here, like we got our 1, but the prefix variable was minus 1. Means there are no prefix zeros. So just do one thing, prefix zeros make it 0. There are no prefix zeros, right? Then there will be else, which we'll see afterwards. So then just move I, this 0, we have 0, so we'll increment zeros variable, it will become 1. Then again we get 0, increment this becomes 2. Again we get I 0, make it 3. Then we get 1, right? We get 1 again. So we will go in this if. Now the prefix zeros are not -1, so we will not go in this if, we'll go in else. Now what we need to do? We need to update our max zeros. These are the max zeros. So max zeros will be maximum of whatever the current value of max zeros and the zeros variable, these zeros. So this will, max zeros will become 3. And see, we got these consecutive zeros now. Now after this one, we will get again consecutive zeros. So for that, we again have to make this variable 0 so that we can get the consecutive zeros after that. So this over here, we will do zeros is equal to 0. Again, initialize this variable to 0. Again, we will traverse. So we'll get again 0. This will increment. And again, we get 1. So again, we get 1. And prefix value is not -1, so we will not go in this if, we'll go in else. Max zeros will update with the zeros value if it is greater, but it, here we have 3 and this is 1, so we will not update it. And zeros we will again make it 0. So we have traversed this, see, we have traversed this, and after traversal we have to update our suffix. We have to update our suffix zeros to be zeros variable. Why? Because it may happen that after this one there will be zeros. So for that, our zeros variable will have the zeros which are after this one. But over here there were not, right? There were not. So after that, suffix zeros will be zeros. Whatever there are, count in the zeros variable. So this was our approach, and after that, what you just need to do is you have to return the maximum of prefix zeros, suffix zeros, and the max zeros divide by 2. So this will be the closest distance, maximum closest distance. Alright, so I hope you understood this approach and the dry run. So the time, let's see the code quickly. Java code will be in the description, so you can check that also. And just quickly see the code. We are taking 3 variables, prefix, suffix, and the max. And this is the zeros variable, initialized to 0, and the rest are initialized to -1. Then we are taking this for loop, we are traversing. If the seed is 0, just increment zeros variable. Else, what we were doing, see, in the else we were checking if the prefix 0 is -1. If prefix 0 is -1, update prefix zeros to be zeros. So yes, over here you need to make it zeros, right? Because whatever the current zeros we have to update that in this. Else, what you need to do, update max zeros with zeros. And again, after this, just update your zeros to become zeros again. And at last, after this for loop, suffix zeros will become whatever zeros are there at the end. And we'll return maximum of these two and this. So I hope you understood the approach. The time complexity for this is O of n, single traversal, and O of 1. We are not taking any extra space. Right, so this is the optimized approach. Other approach will also get accepted, but that was not an optimized approach if we take the space complexity. I hope you understood the like both the approaches, and the video was quite lengthy, but if this video was helpful, please like it, subscribe to my channel, and I'll see you in the next video.